This is lesson 6 in section 2, or lesson 26 overall. Equations are the most commonly encountered aspect of any mathematics program. Your ability to work with them determines how successful you will be. This lesson will extend your understanding of them. By this stage of the course, you should have a good equation solving skills, and a little extra work will ensure that they give you an excellent foundation for later topics. We are going to look at 4 related maths questions. Despite the fact that they all share the same introduction, the differences in the information supplied change how we develop a solution. This lesson will allow you to experience the evolution of a simple problem into one which is quite complex. Here's question 1. Fred went to the shop to buy pens. He got 15, 10 of which were black. How many were red? This looks like a standard maths question. It obviously contains 3 distinct parts: a setting, some data, and a specific task. So when we turn the problem into a solution, we focus on what the main concept is. And in this case, the concept is total. So we build our structure on the formula for total. The total number of pens is equal to the number that are black, plus the number that are red, plus the number that are yellow, plus etc. Now, when we substitute the information we are given, we have a clear total, 15, and the number of black are 10. But can you see that the information supplied for the other possibilities is inadequate? That means we cannot calculate a unique solution. What we can do is say the number of possibilities is somewhere between 0 and 5. Can you see why 6 isn't a possibility? We can illustrate what's happening with a graph. Here I've put the number of black pens as the vertical axis, the number of red pens as the horizontal axis. Now, having 10 black is consistent with 0 red, 1 red, 2 red, etc. But we don't need the graph to go beyond 5 red because 6 isn't feasible. So what have we learnt from looking at this question? Firstly, we need a value for all variables except the unknown. And if not enough are supplied, no specific answer is possible. In order to generate a unique answer, a question must contain adequate data. That puts the onus on the person who's making the question to ensure that it is a satisfactory question. Now for question 2. Fred went to the shop to buy pens. He got 15, 10 of which were black. How many were red? That's the previous question. But this one contains some additional information. The others were red. The question includes a little more information, and we will look at how that affects the solution process. Knowing that the pens were either red or black simplifies our description of what can happen. When we make our formula to represent what's happening, total number of pens is the number of black and the number of red combined. There are no other possibilities. So the data we have been given is now adequate. 15 pens in total and 10 black. So using our equation solving process, we calculate that the number of red pens is 5. In other words, we get a unique solution. Our approach is the same in both cases. We begin by stating the nature of the problem and using a formula to express its structure. Then we substitute the given information. We use the data which has been supplied. Because there's only one unknown in question 2, we can calculate an answer. A graph helps clarify what we're dealing with. Notice that I've used the number of black and the number of red as the axis labels. We know the total is 15 pens, so the line is going to represent 15 pens. This point on the line represents 15 black and no red. This point, 15 red and 0 black. Each point in between represents a possibility generating 15. The required solution is the point that's consistent with information we have been given. We were told there were 10 black, so there must be 5 red. So notice how the graph illustrates what we are dealing with. It lists other possibilities which might be appropriate in other questions. Notice how the graph has been drawn. The axes represent things that can change in the context of the problem. Although the structure of this calculation is based on total number of pens, in this problem the total has been set at 15. So in the sketch, the total is represented by every point on the line shown. The highlighted point is level with 10 black, which were specified, and 5 red, which were calculated. So here's the whole solution. The problem, the analysis of the problem, the calculation leading to an answer, and the graph which illustrates what is happening and what could happen in other situations. Now for question 3. Fred went to the shop to buy pens. He got 15, 10 of which were black. The others were red. Now look at the information that's supplied. Fred paid $25 for the pens. The black pens cost $2 each. What is the cost of a red pen? Now the focus has changed from the quantity of pens to the cost. So we must work in dollars. The concept is still total, but it is total cost. So our formula to represent the problem is total cost is the cost of the black plus the cost of the red. Notice we are working in subtotals. The question wants to know the cost of one red pen. It gives us the cost of one black pen. So the total cost is made up of the cost of the black, cost of one black by how many of them we have, and the cost of a red pen by the number of red pens that's relevant. When we look at this equation and relate it back to the question, we can substitute the data. 25 for the total, $2 for a black, 10 of the black, 5 of the red. We can work out the cost of one red. To do so, we tidy up this equation, shift things in the usual manner, and draw the conclusion the cost of a red pen is $1. So here's the structure of the formula for this problem. Total cost is the cost of all the black plus cost of all the red. The question supplies the cost of each black pen, so we calculate the value of all the black pens by multiplying the individual cost by the number of pens. This is a standard thing we do regularly in everyday life to get a total. But in this case, it's only a subtotal because we have two different types of pens to focus on. When we do it for the red pens, the individual cost is the unknown, and it remains in the equation represented by cost of the red, but remember, we abbreviate. In this case, we have our problem, we have turned it into a solution, and here is a possible graph which will illustrate it. This time I'm illustrating the relationship between total cost and the cost of red pens. There is the cost of the black pens. So we begin by knowing $20 of the cost was due to the black. Then that cost will increase depending upon the cost of the red. For every extra dollar in the cost of a red pen, the total will increase by 5 because we are dealing with 5 of them. So $20 cost of the black, 25 if it's $1 each for the red, 30 if it's $2 each for the red, 40 if it's $4 each for the red. Notice the 20 can be considered a starting possibility, and the graph increases based on what we know about the red. So this graph illustrates the problem. It uses total cost as the vertical axis. The total cost is 20 plus 5 times whatever a red pen costs. The vertical intercept, $20, is the cost of the black pens. And every additional dollar in the cost of a red pen lifts the graph by $5. The point highlighted here is where the structure of the graph matches what we know about the situation. The pens cost a total of 25. Now we move to question 4. Again, the introduction is the same as before. But here is the change. He later returned and purchased 10 black and 10 red pens for $30. So this question is not indicating the unit price or individual price for either type of pen. It is supplying us with two totals. It asks for an individual price, the cost of each type of pen. So in actual fact, it's asking for two things. So notice that the question does not supply the individual price for any of the pens. However, it does supply new information in details about the second purchase. And that information, the $30, is another total. So here we turn the problem into a calculation. It's clearly based on total, built up from subtotals for the black and the red. But when we substitute the given information, we find we have two equations that are relevant. One uses the $30 total, and the other uses the other purchase situation, which was $25. As we've seen earlier, we cannot solve an equation with two unknowns, but we can solve equations when there are two unknowns if we have two equations. So what we have to do is combine the information in these two equations to give us our result. Now, if we add these equations together, we get $55 was the cost over the two purchases. That's not helpful. But if we subtract the two equations, we find $5 is the cost of the additional 5 red pens. And once we have this equation, we can solve it. $1 is the cost of a red pen. Combining equations like this is referred to as elimination of one of the unknowns. And here, the elimination was based on subtracting one lot of information from the other. And when we did that, the contribution of the black pens was removed. We still have our three-step process. What's the formula which describes the structure of this problem? Substitute the data that we have been given. That didn't give us one equation, so we manipulated them to get one equation, which we could then solve. Still a three-step process. Now, this problem required two answers. It asked for the cost of the red pens, which we've calculated, but it also asked for the cost of the black pens. And now we know what the red cost. We can go back to either of the equations we had, choose one of them, use the cost of the red to find the cost of the black. So now we know a red pen costs $1 and a black pen costs $2. When we look at the graph in this case, we have two equations. So we can draw a graph representing a total of 30, a graph representing a total of 25. Here are our two total graphs, and where they intersect represents the common information, common data for both cases. So what we have here is a black pen costs $2 and a red pen costs $1. When we're dealing with fixed totals, the axis labels are the unknowns, the two costs. Did you notice how all these questions shared a common introduction? And they were based on the same two items. And they involved type 2 maths, which is the calculations. In each of those, the understanding of the calculation is helped by an illustration. And that can involve sophisticated thinking. Type 2 maths calculation use a strategic format. The same 3 steps in the same order. The first sets up a structure, which is described by the question. The second uses information, which is supplied in the question. And the third extracts a conclusion by using our standard solving technique. The following chart shows the 4 questions side by side. The strategic nature of a solution is expressed vertically, and horizontally the 4 questions display a transition from inadequate information to quite complex data. So here we have the 4 problems side by side. They all share the same introduction. The setting, he went to the shop to buy pens. The initial data, he got 15, 10 of which were black. Then we have our different tasks. How many were red? How many were red? In this case, the inadequate data meant we couldn't get a unique solution. In this case, the additional information that the others were red gave us a unique solution by a standard 3-step calculation. In the third question, there's a transition from the number of pens to the cost of the pens. Fred paid $25. So that means our initial equation is based on a total is made up of subtotals. That's common sense. We all use that in everyday life. So here we substitute the given information, one unknown remains, and we can find its value. In the last case, we weren't given any information about a specific item. All our information was in the form of totals. He paid $25. Next time he paid $30. So here, even though we used the same equation to set up our calculation, we use a double substitution because there are 2 unknowns, but we can manipulate that to find an answer. Once we know a red pen costs $1, we can use that to unlock the fact that the black pens are $2. In each case, a graph can illustrate what we're dealing with. In the first problem, numerous possible answers. We can't be specific. In the other cases where the data is adequate, we can find the one result which represents the answer to the problem. So there we have calculated 4 answers for 4 related problems. You should have a better understanding of how a maths problem should be constructed. We have our one approach for solving, but there are numerous possibilities for giving us the relevant information, and these make the problems look very different. We'll move on from there next time. See you then. Here's a graph to help clarify what we're dealing with. Notice number of black against number of red. They are the things that can vary. We know the total number of pens is 15, so we can't use that as one of our axis labels. Before we do the calculation,